Hi, at 12. I'm going to show you how to do some of these exponential modelling questions because it ties together all of the things that we've learned so far in this chapter, and I'm going to show you the kind of common things that you're going to get in an exam. So I'll show you this first one. It's to do with a population of orchids modelled against time. When I read the question, I always make sure that I'm checking the units that are used because you never know if that might change in the question. It might change to things like months or days. All right, so given there's 300 orchids when the study started, so when I read that, I'm looking at and thinking about initial value, so t equals 0. And this 300 is the value of p. So using that, show that a is 0.12. Just need to put everything into it. Remember that e to the 0 makes 1, so you're going to end up with this. 300 is 2800a over 1 plus a. Okay, again, the e's disappear because e to the 0 is 1. Then it's just standard stuff now. You can solve for a, multiply through on the denominator. So 300 plus 300a is 2800 times a. Subtract, divide, so 300 is 2500a. And then I'm assuming when you divide those, you get 0.12. Okay, that's 3 marks worth for the first question. Using the equation then, this is part B, using that value of A, predict the number of years before the population of orchids reaches 1850. So this is now my value of P, and I'm after a value of T. So I can put A in now as well. P equals, actually no, P is a given value, 1850. Equals, okay, 2800 times 0.12 e to the 0.2t over 1 plus 0.12 e to the 0.2t again. Okay, let's tidy this up a little bit. 2800 times 0.12 is 336. Okay, then multiply through on the denominator again. So that's just the numerator there. So I'm going to do 1850 plus, and then this times 1850 is 222. Okay, and then these two are like terms. I can subtract those and then hopefully get myself towards the value of t. So 1850 equals, what's this going to be? 114 e to the 0.2t. Divide by 114. Okay, 1850 divided by 114. It's about 16.22. Okay, now we're trying to get towards the value of t, so we need to take natural logs since we've got an e here. So take logs, natural log there, natural log there. So then 0.2t, that's the power of e, is a natural log of that. 2.7867, something like that. And then you can times by 5. So I make 13.933 years, which is about 14. Okay, so that's B done. Now I need to show that p equals this thing here. Well, let's write down where we got to with expressing p in terms of t. We've got what is it initially? It's this thing here, 336 with an e on it over 1 plus, and then it's a, which is 0.12, e to the 0.2t. Okay, so that's as far as we've got, but look at what it's supposed to look like. It looks like we need to drop this e to the 0.2t everywhere, and if I divide everything by this e term, it goes straight towards what we're supposed to have here. Okay, we're supposed to get this negative power of e. So I'm going to do that on top and bottom. I'm going to divide by the e term. All right, and then that disappears. The 1 becomes this e to the minus 0.2t there, and that becomes that term, and then that disappears, so it becomes just 0.12, and you're done. Okay. Now, it's helpful to write our formula in this term, in this way, because of the next part. Okay, it shows a limiting value on p. So hence show that the population cannot exceed 2,800. Well, I'm going to draw a box. I've got more space first. And then I'm going to copy this formula down below. Okay, so taking a look at this thing here, we need to see what possible values p can have. Well, the only thing that changes the value of p is this term down here. If I increase t, then this term is going to go to 0 because of the negative in the exponent. So this thing here, it's an exponential, so I know it has to be bigger than 0, right? And if I push it towards 0 by increasing t, then because it's in the denominator, the whole thing is going to approach a value from below. So when that happens, this thing can only go as far as 336 over 0.12 plus 0. Okay, when that goes to 0, this is the limiting value, but it can't reach that value because of the blue bit. Okay, the fact that this can't actually be equal to 0. So that's our limiting value. That's our kind of upper bound. And if you divide those, hopefully you should get your 2,800. Let's just double check. 336 divided by 0.12. Yes, 2,800. Okay, quite a common question that, to put it in that particular form and then just basically put that towards 0 and see what happens. Okay, so that's how many marks? 7, 8, 9, 10 marks there, just for doing all of that stuff. Just another word of warning for the next part. I won't go through the whole question, but if you see the word rate, which it does say that in that second question, where is it? Here, find the rate. Anything to do with rates is a derivative, okay? A rate of change, you want to do something by dt, okay? d by dt of something. Okay, so that's kind of a trigger word for finding the derivative, not the value of t itself. Okay, so this be d capital T by dt. Okay, best of luck with these questions, okay? This is the final part of the entire year, you'll be pleased to know. Okay, so once you've done it all, hopefully you can get it all consolidated and work out which bits you need to focus on for your revision. Okay, thanks very much, Year 12. Have a great day.